Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 846, Hand of Straights. This is a medium difficulty Leetcode problem, and the problem description tells us that Alice has some number of cards, and she wants to rearrange the cards into groups so that each group is of group size, and consists of group size consecutive cards. And we're told that we're given an integer array hand, which has the values written on the ith card. And so each element in our hand list is a card represented by an integer, and we want to return true if we can rearrange, or if Alice can rearrange the cards, or false if she can't. So basically, given a list of cards, can we make can we rearrange them all into groups of group size and make sure that they all are in a consecutive sequence. So in this example, we return true because we can rearrange these cards into 1, 2, and 3, 2, 3, and 4, and 6, 7, and 8. We can see that they're all consecutive. And not only are they consecutive, they all abide by the fact that they are of group size 3, right? In this example here is false. We can't rearrange these. We can't rearrange the cards into groups of 4. So how are we going to solve this problem? Well, let's look at, we can see that, 2 and 3, these numbers occur, they occur twice, but they can, appear as many times as possible, really. So we know that we can have multiple cards that appear multiple times, right? And so what does this say? Well, it tells us that we may need to store this in a hash map. We want to count the number of times each card actually appears. And then we want to go through each, we want to sort our cards. We want to start off from the smallest card. We want to start from the minimum, from the smallest card, because we want to be able to create a consecutive sequence. And we want to check for each card, are there enough consecutive cards to complete that group? So, let's say, 1, 2, and 3. Let's take that as an example. So we have 1 appears once. Therefore, because the group size is 3, we know that 2 must also appear once, and so must 3. 2 and 3 must also appear once to satisfy this group, and they do. If 1 appeared twice, well then 2 must appear twice, and 3 must also appear twice. Let's look at this example, right? And let's look at another condition. Let's say we have 2, 3, and 4. We start off from 2. Well, 2 appears twice, therefore 3 must appear twice, and 3 does appear twice, and 4 must also appear twice, but it does not. It only appears once, so therefore we would return false. So it's quite simple. We basically want to create a hash map and say, can we, for the number of times that we come across the number of occurrences for a card, can we build a sequence? Are there enough cards to build that consecutive group, that consecutive sequence? So that's what we want to do. Let's get to coding this problem up. So first thing we want to do is actually just say, are there enough cards to make all the groups to be arranged into groups of group size without any remainders, right? So I want to say, if the length of our hand mod group size, if it is not equal to 0, well then we know it's not possible to actually rearrange all these cards into groups of group size, so we just return false. We don't need to do any computation, saves us a bit of time. Otherwise, we want to create a counter and pass in our hand, and this will basically have each number with its corresponding count, right? And then what we can say is, like we said, we want to start off from the beginning, right? We want to start in a consecutive order. So what do we want to do? We want to say, for I in range, and actually no, not in range, we can just say sorted, right? We can just get the number straight out. So we can get, for I in sorted count, sort our counts, sort our cards, sorry. We're going to say, if count hand is greater than 0. If it's equal to 0, we don't do anything. We don't need to worry about it. If it's greater than 0, then we want to get the number of times with the number of occurrences of this card. And then we just want to do the logic that we discussed. So we want to say for I in range group size, if count card plus I, so if there are consecutive cards, count card plus I is less than the number of occurrences. If it's less than the number of occurrences, then we just return false, don't we? Otherwise, we say otherwise, we wouldn't do anything. But what do we want to do now? Well, we've already visited this this card. We've already used up the number of occurrences, for this occurrences of cards. So we can just say count card plus I minus equals number of occurrences, because we don't want to we want to subtract those occurrences so that on the next iteration we have the correct amount. We don't want to keep the amount the same, because then we're not factoring in that we've already used those occurrences, if that makes sense. And then we just want to return true if we finish this for loop without returning false. That means we can make groups of group size and rearrange all of our cards into these groups. So let's submit our code and check that works. And it does not. Why does it not? Because we should say if count of card. Actually, we should say for card and sorted. I don't know why I put either. So for each card and sorted, and that passes all 92 test cases. So I hope this problem description and the problem solution makes sense. A bit confusing initially to wrap your head around, but really, I think some people do kind of use you can use like a minimum heap to store the minimum card value on each iteration. But you can, that's not really required, because we can just factor in the fact that we, for each card, we just subtract all the occurrences as opposed to subtracting a single occurrence and then having to store, all our occurrences in like a min heap, and then find the minimum card again. It's long. So the best kind of option really is to do this in a single pass, simply by subtracting all the occurrences from each of our consecutive cards that we find. So I hope that explanation kind of makes sense. In terms of time complexity, well, we are sorting, so it's going to be big O of n log n. If I can squeeze that in there, that would be nice. And space complexity is going to be big O of n. So with that being said, guys, I hope you enjoyed this video, and I'll catch you in the next one.